Hello, welcome back. In this tutorial, I'm going to write some more example functions that's going to help you to understand function in a better way. And let's take one example now. Let's write a function that's going to check whether a supplied number is prime number or not. We know the definition of prime number. A number is prime number if it is only divisible by 1 and that number. That means it doesn't have divisors other than 1 and that number. Now 13 is a prime number because we can divide 13 only by 1 and 13. 20 is not a prime number because apart from 1 and 20 we can divide 20 by 2, also 5. So 20 is not a prime. So a number is prime number if and only if it has divisors 1 and that number, nothing else. So in order to find out whether a given number is prime number or not, we need to go on dividing the number from 2 up to the square root of that number, because that's the necessary and sufficient condition according to the mathematics. Because if the number doesn't have a divisor in the range 2 to that square root of that number, then it cannot have a divisor in the other range as well, after the square root as well. So we need to run a loop starting from 2 and we need to go up to square root of that number, and we need to check whether that number has a divisor in that range or not. If any divisor is found, then it's not a prime number. Otherwise, if no divisor is found in that range, then it's a prime number. Okay, so we are just writing this function is prime is going to check the supplied parameter n, that's the number n supplied as parameter is prime or not. If the number n is prime, then it's going to return 1, otherwise it's going to return 0. So we are just taking a loop counter, say I, and we start from I equals to 2, and we need to go I less than equals to square root of n, and I will be incremented each time by 1. Since we are using sqrt function in order to calculate the square root of the number n, so we need to include the header math.h because the declaration of sqrt is given in math.h. So now in the for loop, we need to check whether I is a divisor of n or not. If I is divisor, that means we just need to check n%i. If that is 0 equals to 0, then I is obviously a divisor. Now n%i is 0 if only I divides n. Okay, so if I is divisor, what we need to do is to return immediately without doing anything else 0. Then the function gets terminated and the value 0 is returned to the caller. So if we come out of the for loop up to checking up to the square root of n, then it's obvious that we didn't find any divisor in the range 2 to the square root of that number, and obviously it's a prime number. In that case we should return 1. So that's all. It's the prime number checker. So now we can just check and print all the prime numbers, say between 10 to 100. So if I need to print all the prime number between 10 to 100, I can just write a for loop here starting the count from 10, and we should go less than equals to 100, and each time I'm incrementing count by 1, and then if the count is prime number, and for that what I'm doing, I'm calling the isPrime function within the if. As you can see that I'm calling it here. Now I'm passing count to the isPrime function. If the isPrime function returns 1, then if is going to take the result of the condition as true. So in that case we should print yes, it's prime number, %d is prime. So we are printing count. Otherwise, if it is not prime, I'm just not printing anything. It can happen. We may ignore to write the else part. So if the number is prime number, then it's returning 1, is prime is returning 1, and we are just printing that it's prime number. Otherwise it would return 0, and in that case we are doing nothing. So let me just run the program to show you that it's really printing the prime number in the range 10 to 100. Okay, here we go. You can see that these are the prime numbers in the range 10 to 100. 11 is a prime number, 13 is prime, and so on the others. So that's it. We have written a function that's going to check whether a given number is prime number or not. So we can use this function in our program to determine a prime number or not. Now going ahead, we can use this isPrime function from some other function if we need so. For example, if say we are asked to write a function that's going to find out the sum of all the prime numbers in a given range, then we can just use this isPrime function in that particular function. Say I'm writing the function to find out the sum of all the prime numbers in a given range. So the function name can be given sum of primes, and I'm just giving the lower bound from which we should start and up to the upper bound. So we need to just find out the sum of all prime numbers in between LB and UB, both inclusive. So what I'm doing, I'm just writing a counter here, declaring a counter here, and we should start and also we should have a variable sum, and I'm starting from count equals to lower bound, and sum should be initialized with 0 because I'm going to accumulate the sum of the prime numbers here in the variable sum if the count is prime number, and we should go up to count less than equals to upper bound. Okay, and each time I'm going to increment the count by 1. So now within this loop I need to check if the count is prime number or not. If it is prime number, then I need to add this count with the sum variable. So I'm calling the isPrime function in order to check whether count is a prime number or not. So I'm just calling it from here, and as you can see that if it is prime number, that means if the count is prime number, what I should do, I should just add it up with the sum variable. And when the for loop ends, that means when the count goes upper bound plus 1, then the condition count less than equals to upper bound becomes false, and we come out of the for loop and we get the sum of the prime numbers in the range lower bound to upper bound, both inclusive, in the variable sum. So I'm returning the variable sum to the caller. So here is the function. So now if I call this function, that means sum of primes, I'm going to get the sum of all the prime numbers in the range lower bound to upper bound. So I'm just calling that function. Here I have commented the previous code here in the main that was finding the prime number in a range. So I'm just having a variable s here and calling the function sum of primes and passing say 10 to 200. My intention is to find out the sum of all the prime numbers in the range 10 to 200, and sum of primes is going to do that. So sum of primes in the range %d to %d is %d. Okay, so the first %d is lower bound, that means it's 10. The next one is upper bound, that's 200, and we need to print s here. Okay, I'm running this. As you can see that it's 4210. That's the sum of all the primes in the range 10 to 200. Now we can change the parameter here and we can get the sum in the other range as well. We can take the lower bound and the upper bound from keyboard or from a file, and we can again find the sum of the primes. So you can see that we are calling this sum of primes, and here we are using this isPrime function. So if we write a function, we can modularize in any way and we can plug in that function anywhere we need the function.